Question 8. Sum of 1 to n natural numbers is 36. Then find the value of n. Here's the solution. It is given that the sum of 1 to n natural numbers is 36. Therefore, Sn is equal to 36. A is equal to 1, and the common difference, that is d, is also equal to 1, as they are natural numbers. By substituting the values in the formula, Sn is equal to n upon 2 into 2a plus n minus 1 into d, we get 36 is equal to n upon 2 into 2 into 1 plus n minus 1 into 1. On simplifying, we get n minus 8 is equal to 0, or n plus 9 is equal to 0. Therefore, n is equal to 8, or n is equal to minus 9. But n belongs to natural numbers. Therefore, on discarding the negative term, we get n is equal to 8. Question 9. Divide 207 in 3 parts such that all the parts are in arithmetic progression, and the product of the two smaller parts will be 4,623. Here's the solution. 207 is divided into 3 parts. Therefore, let the 3 parts be a minus d, a, and a plus d. According to the first condition, a minus d plus a plus d is equal to 207. Therefore, 3a is equal to 207. Therefore, a is equal to 69. Now, according to the second condition, a minus d into a is equal to 4,623. Therefore, 69 minus d into 69 is equal to 4,623. Therefore, 69 minus d is equal to 4,623 upon 69. Therefore, 69 minus d is equal to 67. Therefore, d is equal to 69 minus 67, which means d is equal to 2. On substituting the values in a minus d, a, and a plus d, we get So the answer is, the numbers are 67, 69, and 71. Question 10. There are 37 terms in an arithmetic progression. The sum of 3 terms placed exactly at the middle is 225. And the sum of the last 3 terms is 429. Write the arithmetic progression. Solution. Let the 3 terms placed exactly in the middle be T18, T19, and T20. According to the first condition, T18 plus T19 plus T20 is equal to 225. We can write these terms as a plus 17d plus a plus 18d plus a plus 19d is equal to 225. Therefore, 3a plus 54d is equal to 225. On dividing the whole equation by 3, we get a plus 18d is equal to 75. Let us denote this as equation 1. According to the second condition, T35 plus T36 plus T37 is equal to 429. Therefore, a plus 34d plus a plus 35d plus a plus 36d is equal to 429. Therefore, 3a plus 105d is equal to 429. On dividing the whole equation by 3, we get a plus 35d is equal to 143. Let us denote this as equation 2. On subtracting equation 1 from equation 2, we get (17d is equal to 68). Therefore, d is equal to 4. On substituting the value of d is equal to 4 in equation 1, we get a plus 18 into 4 is equal to 75. Therefore, a plus 72 is equal to 75. Therefore, a is equal to 75 minus 72. And therefore, a is equal to 3. Therefore, the first term of the arithmetic progression, which is a, is equal to 3. And the last term will be T37, which is equal to a plus 36d. So that is equal to 3 plus 36 into 4, which is equal to 3 plus 144, that is equal to 147. So the answer, the required arithmetic progression is 3, 7, 11, and so on, up to 147. Question 11. If the first term of an arithmetic progression is a, the second term is b, and the last term is c, then show that the sum of all the terms is a plus c into b plus c minus 2a, the whole upon 2 into b minus a. Solution. It is given that the first term, t1, is a, t2 is b, and the last term, that is tn, is c. On substituting the value in the formula of tn is equal to a plus n minus 1 into d, we get c is equal to a plus n minus 1 into b minus a. Therefore, c minus a is equal to n minus 1 into b minus a. Therefore, n minus 1 is equal to c minus a upon b minus a. Therefore, n is equal to c minus a upon b minus a plus 1, which is equal to c minus a plus b minus a, the whole upon b minus a, is equal to b plus c minus 2a upon b minus a. To determine the sum of all terms, we will substitute the given values in the formula of Sn. Sn is equal to n upon 2 into t1 plus tn. Sn is equal to b plus c minus 2a, the whole upon b minus a upon 2 into a plus c. Therefore, Sn is equal to b plus c minus 2a into a plus c, the whole upon 2 into b minus a.
If the sum of p terms of an AP is equal to the sum of q terms, then show that the sum of its p plus q terms is 0, where p minus q is not equal to 0. Solution. Let a be the first term and d be the common difference of the given AP. Then we can say SP is equal to SQ. Using formula, Sn is equal to n upon 2 into 2a plus n minus 1 into d, we have p upon 2 into 2a plus p minus 1 into d is equal to q upon 2 into 2a plus q minus 1 into d. Therefore, p into 2a plus p minus 1 into d is equal to q into 2a plus q minus 1 into d, multiplying by 2. Therefore, p into 2a plus p into p minus 1 into d minus q into 2a minus q into q minus 1 into d is equal to 0. Therefore, p into 2a minus q into 2a plus p into p minus 1 minus q into q minus 1 into d is equal to 0. Therefore, 2a into p minus q plus p square minus p minus q square plus q into d is equal to 0. Therefore, 2a into p minus q plus p square minus q square minus p plus q into d is equal to 0. Therefore, 2a into p minus q plus p minus q into p plus q minus p minus q into d is equal to 0. Therefore, 2a into p minus q plus p minus q into p plus q minus 1 into d is equal to 0. Therefore, p minus q into 2a plus p plus q minus 1 into d is equal to 0. Therefore, 2a plus p plus q minus 1 into d is equal to 0, since p minus q is not equal to 0. Let this be equation 1. Now, sp plus q is equal to p plus q upon 2 into 2a plus p plus q minus 1 into d, which is equal to p plus q upon 2 into 0 from 1, which is equal to 0. Therefore, sp plus q is equal to 0. Hence, proved. If m times mth term of an AP is equal to n times the nth term, then show that m plus nth term of the AP is 0. Let a be the first term and d be the common difference of the given AP. Then it is given that m times mth term is equal to n times nth term. Therefore, m into tm is equal to n into tn. Now, tm is equal to a plus m minus 1 into d, and tn is equal to a plus n minus 1 into d. Therefore, m into a plus m minus 1 into d is equal to n into a plus n minus 1 into d. Therefore, m into a plus m minus 1 into d minus n into a plus n minus 1 into d is equal to 0. Therefore, am plus m into m minus 1 into d minus na minus n into n minus 1 into d is equal to 0. Therefore, a into m minus n plus m square minus m into d minus n square minus n into d is equal to 0. Therefore, a into m minus n plus d into m square minus m minus n square plus n is equal to 0. Therefore, a into m minus n plus d into m square minus n square minus m plus n is equal to 0. Therefore, a into m minus n plus d into m plus n into m minus n minus m minus n is equal to 0. Therefore, m minus n into a plus d into m plus n minus 1 is equal to 0. M minus n is not equal to 0. Therefore, a plus d into m plus n minus 1 is equal to 0. Let this be equation 1. Now, m plus nth term of an AP is a plus m plus n minus 1 into d. Let this be equation 2. Therefore, from 1 and 2, m plus nth term of the AP is 0.
Question 14. Rupees 1000 is invested at 10% simple interest. Check at the end of every year if the total interest amount is in arithmetic progression. If this is an arithmetic progression, then find the interest amount after 20 years. For this, complete the following activity. Solution. Simple interest is equal to P into R into N upon 100. Simple interest after 1 year is equal to 1000 into 10 into 1 upon 100, which is equal to rupees 100. Simple interest after 2 years is equal to 1000 into 10 into 2 upon 100, that is equal to rupees 200. Simple interest after 3 years will be 1000 into 10 into 3 upon 100, that is equal to rupees 300. According to this, the simple interest for 4th, 5th, 6th year will be 400, 500 and 600 respectively. From this, D is equal to 100 and A is equal to 100. Now, to calculate the amount of simple interest after 20 years, we have Tn is equal to A plus n minus 1 into D. Therefore, T20 is equal to 100 plus 20 minus 1 into 100. Therefore, T20 is equal to 2000. Therefore, the amount of simple interest after 20 years is equal to rupees 2000.